This is our composite functions. We have our g sub x function in terms of a fraction. We have our h of y function in terms of a radical. And then we're asked to plug in the 0 into the g function and then plug that answer into the h function. Now there's a couple different ways you can do it. You can actually take care of this g sub 0 first. So we can have that option. We can first evaluate g sub 0. So you just plug 0 into here. And whatever that answer is, you plug it in for h. And let's go ahead and do that, might as well. So that's kind of the easiest way to approach it since you're evaluating. Usually they don't throw a number inside of here and make it easier on you. You'd have to kind of do it in general. I'll see how that kind of works, and I may have to stop. So we'll go ahead and go for the easy version first, and then I'll show you the more elaborate algebraic way of attacking it. So first, we're going to do g sub 0. It's kind of like order of operations. We start on the innermost set and then we kind of expand from there. So on the inside here is g sub 0, so that would be the easiest one to attack. Wherever I see the x, I put a 0. I'm going to use what I call a skeleton, and I really like this for plugging in, and you'll see it's really valuable for when we do a function inside of a function, like which this one kind of is. So 3 parenthesis, wherever I see an x, I put a parenthesis here. 3 parenthesis minus 5 over parenthesis plus 1. What that does is it makes it very easy to plug in your functions or plug in your numbers without kind of getting confused about some of the ways that it might interact or with how it's set up. So notice that wherever I see a parenthesis, I just put a 0. Not too bad. So we're talking about g sub 0. And it would go in that one. It would go in that one. Okay, then we'll go ahead and evaluate it. We do them separately. The top is separate from the bottom, so once again, it's like order of operations. So that would be equal to, that zeroes out. And on the bottom, 0 plus 1 is just 1. 0 minus 5 is negative 5 over 1, which is just equal to negative 5. All right, so that's our g sub 0. Now, that's g sub 0, and then we plug that into our h. So secondly, now we calculate h of negative 5. H of negative 5. So we're doing it in stages here. We take care of this one, and then that's still inside your h. Then we'll evaluate that. So I'll do my skeleton again, but negative 5 is what's going in there. So many times I'll just kind of do that so I can preserve my skeleton. And h of y, so it's y, it's x. It doesn't really matter what the variables are. We're just kind of plugging in whatever goes into it in this case. So square root 1 minus 3, and then there's my parenthesis that I like. And notice that that's where the negative 5 goes. So we're plugging a negative 5 into here. That equals square root 1 minus 3. Well, 3 times negative 5. Negative 3 times negative 5 is positive 15. Oh, that's nice. Square root of 16 is equal to 4. All right. Now let's go ahead and do it the algebraic way. It's definitely a lot harder the other way. This way is a lot easier because we're evaluating. We don't get caught up in the algebra of the variables. So now I'm going to do h of g sub, and then I'll plug in my 0. Okay. So the h of g sub 0, so the g sub 0 right here, that would be h of, and then I just plug in that function. H of that function, evaluated at 0, is, let's see. I'll just go ahead and plug it in on that one. So that would be 3, and we're doing a 0 for x. Notice how it starts to bend the mind a little bit, kind of getting into it. Minus 5 over 0 plus 1. All right. So what this is saying is, for the h function, that's what I plug in. for the variables on H. So now this is equal to the square root 1 minus 3, and then there's my skeleton to kind of plug things in. I didn't really have an easy way of kind of getting into that stages here. If this were an x that we were plugging in, then it would be a little bit kind of easier to deal with. Okay? So we're plugging all this into here, and that's 3 times 0 minus 5 over 0 plus 1. Okay? So notice how easy it is once you have the skeleton just to plug things into it. That's what I like about it. Okay? And then we would want to simplify this. Now this does exactly what this does in stages. So that's the nice thing about this, if you can recognize what to do first and what to do second. And then this evaluates, that's 3 times 0 is negative 5 over 1. So that's negative 5 over 1, which is just negative 5. 1 minus 3 times negative 5. And then notice we've just kind of linked into what this one is here. 1 plus 15 equals square root of 16, which is our friend 4. All right. One thing I kind of want to look at here, and it's really important to kind of see it in a different context, is this function, it can also be written as h compose, that's a 0, or it's not 0, it looks like a 0, it's an open circle, composed with g, and the number that's going in there is the 0, or the x in this case. So why I bring this up, so this is composition. So this composition here is just a different way of writing this. So these two things are equal right here. So h composed with g of 0, and kind of why I wanted to show you this is it's a little bit tricky, a lot of students get confused with it, is this is one of the few times you work right to left. You go in this direction. So many times they might have the 0 on the left, but we always do our actions going this way. Okay? So another way that you might see it is h composed with g, and then the 0 is on that side. Okay? So even though it's on this side, I like to rewrite it like that so we can see it a little bit easier, and that would be how we evaluate it.